Hello everyone. Today I'm going to share with you our paper, Memory Augmented Multi-Instance Contrastive Predictive Coding for Sequential Recommendation. This work is done with our colleagues at the University of Queensland. In this paper, we focus on the task sequential recommendation with site information. Site information usually includes brand, category, and manufacturers, etc. The challenges for sequential recommendation with site information usually contain two aspects. The first one is the sparsity of the signal in the interactions, because user will generally interact with only a small set of the items. And the second challenges is the feature combinations are also very sparse. It is because some items will just have some very limited combination of the site information, for example, the brand and the categories. So these two sparsity issues are main challenges for the sequential recommendation. And usually the training signals will have the BPR, which is a pairwise training loss. In this loss, there will be one positive sample and one negative sample. And while in the recently very popular training losses, which is the noise congestive estimation, it generally has one positive sample and multiple negative samples. So compared with BPR loss, NCE will introduce more negative samples. So the training signals will be not too sparse compared with the BPR loss. In our paper, we propose a new NCE loss, which will have multiple positive samples and even more negative samples to tackle the sparsity issue for the training loss in the interactions. While to tackle the challenge for the feature combinations, we further propose a memory network to provide a general representation for the items. So the memory network can provide a unified representation. For using contrastive learning, we review a little bit of the related work. The first one is about the computer vision. So in computer vision, contrastive learning usually generates two semantic augmentations and then align the representation of these two augmentations. While in the sequential problem, in sequence representation learning task, two non-semantic augmentations are generally generated by the contrastive learning algorithms because the augmentation for sequence is not straightforward as computer vision. For example, the random job or random order of the sequence are not semantic augmentations. While in our paper, this paper called MMInfoRec, we have the augmentation on the item representation, and we propose a novel dropout-based augmentation in this contrastive learning framework. In a concurrent work in natural language processing area, it is called SIMCSE, which is also based on the dropout in the BERT model. And further, we recently have a newly accepted paper in WSDM2022. So it uses the contrastive learning for the representation degeneration problem in sequential recommendation. So in that paper, we also provide a semantic and model level augmentations on our sequence. So here's a QR code for this even new paper. So we'll continue to talk about this MMInfoRec in our paper. So we have basically three major components. The first one is the feature encoder to encode the item and its site information into a representation. And the second one is a memory module, which can provide a more general representation for every item. And the third one is the multi-instance NCE training objective. So firstly, we'll talk about the feature encoding and the memory module. So the feature encoding function is an attention model. So there will be dropout function inside this attention. And the second one is the GAP, which is the auto-regressive prediction. Usually we use some similar structures like RNN and transformer with the previous work. So they are basically very similar. And the third one is the memory module, GM. So in this module, we have a CT, which means the context or sequence vector, or the representation from the auto-regressive prediction function, and the capital M, which is the memory matrix. So to calculate the prediction representation of your context, we transformed the context vector using the memory matrix, and we use the context vector to calculate a softmax distribution, and then multiply this transformed context with the memory module together, and plus the context vector itself, which is very similar to the residual addition, to calculate the final representation of our model. So here is the complete encoding procedure, and we'll look into the training objective. So in addition to the BPR, we also introduces the vanilla NCE loss. So in the NCE loss, as we discussed in the introduction, there will be one positive sample and multiple negative samples. So in our multi-instance NCE, we propose to use multiple positive samples and multiple negative samples together. So what kind of samples will we use? For example, in the positive samples, we propose to use a semantic positive. So in the sequence prediction, there is a ground truth item. For example, currently, if we are in the time step t, the item in time step t+1 with the ground truth. So when we do the encoding of the ground truth at time step t+1, we use different dropout masks to calculate the encoding for multiple times to generate the semantic positive samples in the nominator here. So well, for the negative samples, we have two types. The first one is the temporal negative, which means that they are the items from the same input sequence, while not the ground truth item. While for the general negative samples, we just choose the items from the same mini batch. So in our experiments, we conduct experiments on 4 datasets, and then the metrics we choose are the NDCG at 5 and at 10, also the hit ratio at 5 and at 10. The baselines we choose to compare are like this GRU4rec, CASA, SAS-rec, BERT4rec, HGN, and they are feature-based version, and also the feature-based sequential model like FDSA and S3rec. So for the overall performance, we observe a few interesting things. The first one is if we can use the features in an appropriate way, or this feature means the side information of items, sometimes it will help. For example, compared with these 2 columns, the feature-based version of GRU4rec will have a great improvement. But while we compared with the SAS-rec and its feature-based version, we can see that the directly usage of feature in this SAS-rec will drop the performance. While in S3rec, which is based on SAS-rec, adding a few self-supervised learning training objectives, it can help to improve the performance. While for our MMInfoRec, we can see that the improvement is kind of relatively huge compared with the baselines here. And if we look into the ablation study of the MMInfoRec, for example, CPC in this column, it serves as the base model. And if we add the memory module, we can see that it basically can have a small proportion to improve the performance. While we add the multi-instance NCE to the base model, we can see that the improvement is even larger. While we combine our 2 modules together to get a complete model of MMInfoRec, we can see that the performance will be the best compared with all of them. So while we also do a visualization of our memory network, remember in the memory module, we have a memory matrix M. So we visualize that M matrix, and then we can see that for each memory slots, most of them are very close to 0. Here is the norm of each memory slots we visualize. So we can see that there will be only a few or very, very few memory slots will be effective for this memory matrix. We think this is a very interesting phenomena. We also compared with these 3 objectives on the same model. So we can see that generally multi-instance NCE is better than NCE, and NCE is even better than the BPR. So we can say that if the model is trained with richer signals, the performance will be better. And in conclusion, we propose a memory network to tackle the sparsity of the feature combination problem. And we also propose a new multi-instance NCE training objective to tackle the sparsity of the interaction problem. So for future work, we extend the token level dropout to sequence level to have a good semantic augmentation for sequential recommendation. So we have also a newly accepted work to the Wisdom 2022. So here is the QR code for the future work paper. And here's the reference. And thank you so much.